Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the problems on impact of elastic bodies. The course outcome of this session would be recall the concept of conservation of momentum for knowing the velocities and momentum before and after collision on bodies. The topic covered would be problems on impact of elastic bodies. The topic learning outcome is understand the concepts of impulse and momentum and apply these in collision of bodies. Let us go for the first problem. The problem given is a gun of mass 30 tons fires a 456 kg projectile with a velocity of 305 meters per second. With what initial velocity will the gun recoil? And if the recoil is overcome by an average force of 600 kilonewtons, how far will the gun travel and how long will it take? So there is, in this case, there is a gun which is firing a bullet, let us say a projectile with a velocity of 305 meters per second. And the weight of the projectile that is given is 456 kg. The mass of the gun is given as 30 tons. We can convert that to kg, or else we can convert the projectile weight mass that is given as 456 kg into tons. As both of them which are given in the terms of tons, the mass we can convert. There is no need to conversion. Then with the initial velocity of the gun we need to identify. Then if the recoil is overcome by an average force of 600 kilonewton, how far will the gun travel? So we will be calculating the distance traveled by the gun also, and how long will it take. So we will be considering the time consideration also. First, let us see the given data. Mass of the gun is given as m is equal to 30 tons, that is equal to 30,000 kg. And mass of the projectile given as small m, if we consider it as 456 kg. The initial velocity of projectile is given as 305 meters per second, and the velocity of the gun can be considered as v meters per second. Now, if we consider the conservation of momentum, m into v plus m into u is equal to 0, then if we substitute the values as 30,000 into minus v plus 456 into 305, where minus v is considered because the movement of the gun will be opposite to the movement of the projectile. So when you simplify this, you will get the value of v as 4.636 meters per second. So this is the velocity with which the gun will recoil. Then if we consider the motion of the gun, the retarding force F is given as 600 kilonewtons, nothing but it is 6 lakhs newtons. Then F is equal to ma, that is the equation we have. If we substitute the values, we can get the value of A, acceleration, as 6 lakhs by 30,000, that gives 20 meters per second square. Also, we know that v square minus u square is equal to minus 2as. Here minus 2a is considered because it is the retarding force and retarding movement in opposite direction. So the value of S can be obtained as 0.5373 meters. So this is the distance to which the gun travels. And also we do have the equation v is equal to u plus minus at, which gives the value of t as 0.23 seconds. Let us do the another problem. The problem given is a body of mass 2 kg is moving at a speed of 0.5 meters per second to the right, collides with a mass of 3.5 kg which is at rest. After collision, the 3.5 kg mass moves to right at a speed of 0.25 meters per second. Determine the coefficient of restitution. So as per the given data, if we draw the data from the given requirement, we can see the conservation of momentum equation can be written as m1u1 plus m2u2 is equal to m1v1 plus m2v2. When we substitute the values, we can observe here that M1 and M2 are the masses of two bodies, that is object 1 and object 2, and U1 and U2 are the initial velocities of object 1 and object 2, and V1 and V2 are the final velocities of object 1 and object 2. When this is considered and the values as per given data is been substituted in this equation, we can obtain the equation as 2 into 0.5 plus 3.5 into 0 is equal to 2 into V1 plus 3.5 into 0.25. And further simplification, we can obtain the value of V1 as 0.0625 meters per second. Then the value of coefficient of restitution, the equation is E is equal to V2 minus V1 by U1 minus U2. If we substitute the values of V and U, then we will be getting the values as 0.25 minus 0.0625 by 0.5 minus 0. If we simplify this, we will get the value of coefficient of restitution as 0.375. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.